välkomna. Under cirka 10 minuter ska ni få följa med mig, Marie och min kollega Per.
Ni kommer få se aldrig tidigare visade utrymmen och ni kommer få höra historier som ni inte har hört förut och inte visste fanns. Häng med!
Grimeton radiostation stod färdig 1924 och var då en del av ett globalt nätverk av radiostationer av samma slag. Långvågssändarna här i Grimeton de användes för att sända trådlösa meddelanden, så kallade telegram, från Sverige till USA och närmare bestämt New York. Att vi kallar det långvågssändare, ja det är för att de radiovågor de alstrar är väldigt långa, närmare 18 kilometer. Vi ska nu gå in och beskåda det här stora maskineriet som stationen byggdes för. Det ni ser här inne i sändarsalen, det är de stora maskiner som användes för att sända meddelanden med nära nog ljusets hastighet till New York. Grimeton användes bara för att sända information, inte för att ta emot, utan det gjorde man uppe i Kungsbacka. Grimeton var den optimala platsen för en radiostation av det här slaget, för med sin kustnära placering så kunde man sända ut sina radiosignaler utan risk för att de skulle försvagas av eventuella landmassor på vägen över Atlanten. Ett telegram kostade nästan 7 kronor på 1920-talet, vilket var en stor kostnad då och motsvarade ungefär en dagslön för en vanlig arbetare. Behovet av att kommunicera mellan kontinenterna hade länge funnits och dittills tillgodosetts med telegrafkablar som var nedlagda på havets botten, bland annat Atlantkabeln som länkade samman Europa och Amerika. Under första världskriget blev kablarna mål för krigshandlingar, något som resulterade i en strävan efter säkrare och effektivare kommunikationsvägar. Systemen för trådlös kommunikation växte fram.
Sändaren består av flera system och drivs av elektricitet. Innan vi kan starta sändaren behöver vi slå till dessa knivar som finns i det så kallade transformatorrummet för att få kontakt med transformatorhuset cirka 100 meter bort härifrån. Ursprungligen fick sändaren sin elektricitet från vattenkraftverket Ingredsfors lite utanför Falkenberg. Så, nu är det bara att starta sändaren. Eller bara förresten, förutsatt att inga problem uppstår. Sändaren görs körklar på cirka 15 minuter och till detta behövs 2 sändarvakter. Startar du sändaren, tack!
När sändaren var igång fick man ropa till varandra för att kunna kommunicera. Den vanligaste arbetsskadan när det begav sig var just hörselskador. Sändarvakterna tilläts inte att använda något som helst hörselskydd, då man var tvungen att urskilja missljud i maskineriet. Men idag använder vi hörselskydd.
Radiostationen i Grimeton har ett omfattande stationsarkiv som sträcker sig ända tillbaka till 1920-talet. Bland materialet finns bland annat ritningar över det stora långvågssystemet som placerades här och som hade utvecklats av uppfinnaren och ingenjören Alexanderson. Alexanderson var svensk-amerikan och tilldelades under sina verksamma år 344 patent, bland annat det för långvågssändaren som användes i Grimeton. Det som var speciellt med denna sändare var att den var högeffektiv och kunde sända på en särskild frekvens, vilket också gjorde att man kunde tilldela stationen sin egen sändarkanal och en mottagare visste därigenom med säkerhet vem det var som sände. Hans uppfinning gjorde det möjligt att ännu snabbare och ännu säkrare sända trådlösa meddelanden över långa avstånd, något som vi idag tar för givet. Alexanderson är med andra ord ett namn att lägga på minnet och han i hög grad har bidragit till hur vi kommunicerar idag.
vem var det som arbetade på radiostationen? Under bygget samlades många lokalbor som behövde en extra inkomst och arbetet leddes av ingenjör Norén från Telegrafstyrelsen. Han hade fått till sig av den amerikanska leverantören att bygget av en stor radiostation minsann inte är någon barnlek. Därför var det bra att Norén hade erfarenheter av liknande byggen sedan tidigare. Han var anställd av Telegrafstyrelsen i Stockholm och reste ner till Grimeton för att förhandla med bönderna kring införskaffandet av marken. Den ena efter den andra ville vara säker på att varken ta för lågt eller för högt pris gentemot sin granne. Förhandlingar som krävde mycket tålamod och mycket konjak till kaffet. Bygget påbörjades 1922 och stod alltså färdigt endast 2 år efter, trots en omfattande järnstrejk med tillhörande förseningar.
På stationen fanns en mängd olika yrkesgrupper. Ingenjörer och maskinvakter, mastmålare och kontorister för att nämna några. Maskinvakterna de bemannade stationen i 3 skift, det vill säga stationen var i bruk dygnet runt. Under nattpasset ingick att med denna behändiga dammsugare se över golvytorna och snygga till inför den kommande arbetsdagen. För att se till att detta arbete gjordes ordentligt brukade en av ingenjörerna gömma apelsinkärnor i skrymslen och vrår. Och dessa borta när han kom dagen efter så visste han att arbetarna hade gjort ett ordentligt jobb. Dock lärde sig dessa ganska snabbt var han brukade gömma kärnorna och kunde därigenom bespara sig en hel del besvär. Förutom radiostationen och de 6 antenntornen så byggde man också ett antal arbetarbostäder. Detta kommer att bli den så kallade radiobyn där vi befinner oss nu ungefär 400 meter från själva radiostationen.
I radiobyn bosatte sig bland annat stationschefen och ingenjörerna. På kontoret där jobbade fru Bengtsson med all administration och varje fredag radade arbetarna upp sig på led med mössan i hand för att ta emot sin lön. Fru Bengtsson var den enda kvinnliga anställda på radiostationen under många år.
Till skillnad från många liknande anläggningar så kom Grimeton radiostation att bevaras. Och det berodde på att man här dels placerade in nya sändare i stationsbyggnaden och ut på området uppförde man nya antenner. Och än idag är Grimeton radiostation en aktiv anläggning för radiokommunikation. Dels har vi radioamatörer här på området som kommunicerar med likasinnade runt om i världen. Och vissa av antennerna här ute de hyrs ut för att kunna tillhandahålla kommunikation inom bland annat flyg och sjöfart. Genom detta så fyller vi en viktig samhällsfunktion. Detta genererar också intäkter som kan gå till bevarandet av det gamla maskineriet. Och på så sätt bidrar till att levandegöra kulturarvet.
Nu vet du varför just den här platsen är så speciell och ett världsarv sedan 2004. Det är UNESCO, FNs organ för vetenskap, utbildning och kultur, som utser världsarven på världsarvslistan. Den här platsen är helt unik och finns ingen annanstans i världen. Välkommen att besöka oss!
Hello and very welcome to the Alexanderson Day 2023 at the World Heritage Grimeton radio station. We are here to try to start up the 99-year-old transmitter from 1924 and send a telegraphed message to the world at 2 o'clock Central European Time or 12 o'clock UTC. We are all members of the Alexanderson Friendship Association and volunteers that are working with this amazing machine. My name is Anders Börjesson, and I will be your host today. And on my right side, we have our radio operator, Kai Sundberg, who will send the telegraphed message today. On my left side, I have Jan-Åke Gylling, our main operator today. Before we are starting the transmitter, we will take you on a short introduction. So follow me. Over here, everything that is painted black here in the station belongs to the long wave transmitter. I move on. Here we have the Alexanderson alternator with the high frequency generator here. It contains a rotor disc 1.6 meter in diameter with 488 slots on its periphery. It rotates in a magnetic field. And when the disk is up in speed, it generates 17,200 magnetic alternations per second. And that is our radio frequency. So it's here the radio wave is generated. The disk is driven by the main motor via the gearbox. So the speed of the motor is directly related to the speed of the disk or the frequency on the alternator. The main motor is a 500 horsepower asynchronous motor driven by 2.3 kilovolts two-phase voltage. The stator is two-winded and the rotor is three-phase winded. We can control the speed of the motor in two ways. By transductors in line with the stator winding, we can control the voltage. I will show the transductors later on. Via the rotor, it's the second way. The three phases are connected to liquid resistors via slip rings. You can see on the motor shaft there. We are going on to the transformer room and see where the power gets into the building. Now I am in the transformer room, as we call it. Up in the ceiling there, the four nice switches. Here we get 2.3 kilovolt two-phase into the building. On this side we have four transductors where the power supply to the two-phase motor goes through. It is transductors, and that means that's a device where a DC current can control a high AC current, and that's how we control the voltage on the motor. By control DC current, we can control it and give out on the motor from 1,300 to 2,300 volt. We are going back in the transmitter hall. Now, in front of me, we have a set of rectifiers that will give 500 volt DC. It is the current needed for the transductors. One is used, one is a backup. Here we have another set of transformers that gives 125 and 250 volt DC. This is used, and that is a backup. When we are controlling the motor speed, there will be a lot of heat on our contactors in the relay corridor. Here we have two cooling fans that gives compressed air to blow out electrical arcs and cool the contactors. We will use fan number 2 today, and the other is backup. Here we are inside the relay corridor. The more signal gets in here to the first relay, telegraph relay, and is amplified to these 2 relays. This relays is sending a signal to the magnetic amplifier, and this is operating these 4 contactors that will control the resistance on the rotor and provide 500 volt DC to the transductors. We are moving on to the magnetic amplifier. You see it. Yeah. On top here we have the magnetic amplifier. On top here we have collective transformers that collects currents from 64 anchor windings on the high frequency generator and transform it up to suit the voltage on the antenna. At full voltage, 100 amps at 2000 volt leaves the building via the copper pipes up in the ceiling, one for the antenna and one for the ground plane. It is also here that the carrier wave is chopped up in dots and dashes of Morse code, and it is done with these 2 transductors. They alter the frequency on the antenna and by that blocks the amplification when the telegraph key is up. When the telegraph key is down, the frequency is okay and the amplification is okay, and the signal can pass through and out on the antenna. Here are also large tuning coil, variable inductance, and we use it to fine-tune the antenna frequency so we get maximum power out on the antenna. And by that we are going back to the control panel again. And by the control panel we are starting up the transmitter. We controls and tunes the antenna and the transmitter. On this side we have switches, main power switch and motor switch. Up here we have an ammeter to control the power, incoming power to the motor. Here we also have switches for rectifiers. In the middle here we have the so-called automatic speed control system. It's a resonance circuit that works together with one armature winding in the alternator, and it is controlling 500 volt DC to the transductors, and by that the voltage to the main motor. On this side we have a lot of meters that we are monitoring what's going on. Here we can control the speed of the motor, the voltage on the main motor. Up here we can control the power out on the antenna. On top there, up there, we have we can control the frequency out on the antenna and also control the variometer or the tuning coil that we had looked at. On this side, we have a small Morse key to control the transmitter. Here we have knife switches for magnetizing. Down here we have push buttons to control the liquid resistors. And of course, here we also can connect the transmitter to the antenna, to the magnetic amplifier, and then out in the field. Okay, I think we have finished the short introduction. We have done some preparations ahead of time. We have connected the antenna to the magnetic amplifier, and we have controlled all the machines that they are running well, that there are oil in all the bearings. We have no ball bearings here, so the lubrication is of great importance. But we have no power incoming to the building. So I will ask Jan-Åke to go out in the switch yard and have a look. We are going to connect our transformer that converts 50 kilovolts three-phase incoming to 2.3 kilovolt two-phase into the transformer room down there. It looks okay, and with this I will connect the transformer. Now we have 2.3 kilovolts two-phase, and I will ask Jan-Åke to stay with the emergency switch there. So now it is time to start up the alternator and tune it, so we can send the telegraph message at 2 o'clock as planned. I will go over to the left side, and I will close 0 volt release. And now I connect the main power. You can hear an alarm bell ringing, and Jan-Åke temporarily switched off the alarm bell. It says that we have no cooling water or oil pressure to the alternator bearings. Now we are going down to start up the cooling water system. We have 2 centrifugal pumps down here. And we will use pump number 2. The other is a backup. Jan-Åke starts up with opening a bleeding valve to get rid of air pockets in the pump house. He's listening. At the drainage pipe, there will be only pure water coming up. He switch off the bleeding valve and starts up the pump with a star delta switch. Går in där sen. Now Jan-Åke is opening on a ball valve to get cooling water out in the system. We need cooling water at the liquid resistors, at the alternator, and at the magnetic amplifier. And then it goes back again in a loop. It's a rather hard work because he is opening the valve against the water pressure. We can see on the manometer on the wall over there that we are soon having 2 bar or 30 psi water pressure, and that is the nominal pressure. Okay, we are going on. Jan-Åke will control the liquid level in the liquid resistors. It gets hot and evaporates, and sometimes we have to add some, especially in the summertime. This is variable liquid resistors. And I'm waiting for the cameraman, Robert. Here I am. This is here we have variable liquid resistors. The one is backup. This is a start resistor. We use it to control, to minimize the power to the motor when we are starting up, and later on we use it to fine-tune the speed of the motor. It is connected to the rotor by slip rings and cables. This is a control resistor. It is immediately connected in parallel with the start resistor when we are operating the telegraph key, and by that we are lowering the resistance in the rotor and keeps the motor speed up. They both contain 400-liter water mixed with sodium carbonate to get the right conductivity. They also contain several electrodes that are connected to each phase. They also contain an adjustable gate and pump. The pump holds a liquid level and helps to cool the liquid. The gate with the gate we can lift up and down, and by that rise the liquid level, so more or less of the electrodes gets into the liquid, and by that we have a variable liquid resistor. Okay, we are moving on to the relay corridor. Here we have 440 volt on open contacts, and Jan-Åke will start the pumps in the resistors by putting wooden pieces in the start relays. You can hear the water flushing, and I think you can see it on our camera. If we don't start up the pumps in this way, the liquid starts to boil when we start up the main motor. We are going back to the control panel, and Jan-Åke will turn on the alarm bell again. And now we have a persistent alarm because we are lacking oil pressure, lubrication oil to the Alexanderson alternator. So he will close the auxiliary oil pump. By that, we are ready to start up the main motor. Jan-Åke stands with the emergency stop, and I will close the next oil switch. Now you can hear that the main motor is starting up. It slowly begins to rotate. There are great masses to be handled. Only the rotor disc inside the high-frequency generator weighs over 1,500 volt. Here on the ammeter we can see that the power just now is about 140 amps, and over here we have a voltmeter. We have about 1,300 volt to the stator winding. It is limited by these transductors just now. We are waiting for the motor to rev up, and that internal oil pump shall handle the oil pressure, and then we get a signal, and Jan-Åke will turn off the auxiliary oil pump again. We are aiming to about 80 amps. It's a target for us. When we reach 80 amps, we are going to connect two rectifiers. One that gives 125 and 250 volt DC, and one that gives 500 volt DC. It is for controlling the transductors. Yeah, we see on the ammeter that the amperage are going down. I think we have 80 amps, and we are going on. You can connect the rectifiers, and we will listen for the alarm from the auxiliary oil pump. We are going to the right side here, and Jan-Åke will connect the first knife switch. By that, we give 250 volt field voltage to the first to the 500 volt DC rectifier, and now the transducer gets full power, and now we will have 2,300 volt to the motor. You can hear the motor revving up. Yep. And now Jan-Åke will increase high up the level in the start resistor to lower resistance, and then we get even more power to the motor. We are controlling the motor speed at 700. We must control the next knife switch. The voltage is still 2,300. The speed of the motor is 700, and we have magnetized the alternator. Just now we have a radio wave inside the alternator, but not out on the antenna. On top of the panel, we can follow the frequency with this modern frequency counter. Jan-Åke will now go on fine-tuning the speed with the start resistor. The frequency is increasing. Just now we have 15.3 kilohertz and 16.0 kilohertz. We are monitoring the voltage to the motor. It's now decreasing. We are aiming to about 1,900 volt. It's a voltage. It's a voltage that is the automatic speed control system works better when we have 1,900 volt. Just now we have our frequency is 7.17. We are aiming to 17.2. We have the motor voltage. Now it is 1,900 and we are very close to 17.2 kilohertz. Yeah. Now Jan-Åke will control the transmitter with the Morse key. And then he is working with the control resistor. Because we must keep the speed on the motor constant even when we are keying it. Vad är det?
Antennkniv och fläkt.
Ja.
Innan ni ringer.
Ja. Jan-Åke will start up the cooling fan. Of course, we must have the cooling fan running before we are keying the transmitter. Just det. Now we are connecting the transmitter to the magnetic amplifier and the antenna. So now we are out on the antenna and we are controlling are controlling the transmitter and the control resistor. Okay, we can. I think we can switch on the reader. You have to. Yep. Now we are turning on a punch reader. This reader converts the characters on the tape to Morse code. And it will say www SAQ. www means in Morse code hello, hello. Je is here in French, and SAQ is this station's call sign. I think I will go out. I think it's time for me to take on a short tour outside the building to the antenna. Fem minuter högst. Outside here we have a Swedish summer day, a little bit cloudy but warm. It's really nice. In the back of me here at my right side we have our cooling water pond with a fountain running. Behind me you can see the 6 mighty towers against the sky. The towers is 127 meters high with the cross arms up there 46 meters. The highest building in Sweden when it was built. The end towers weighs 160 tons, the towers between 130 tons each, and the distance between is 380 meters. The antenna, total length of the antenna is 2,200 meters, and the ground plane has the same length, but is 500 meters wide, and has deep buried metal wires by a total length of 180 kilometers to lower the losses to the ground. We can follow the 8 antenna wires, the top net, up to the towers that supports the antenna. It is used to distribute the power and the signal via the first tuning coil and up to the top. From the top of each tower there is a vertical radiant attached to the top net. It goes down to the ground via the tuning coils. And it is here that the vertical polarized radio wave are generated. And it is here in these wires, that these radians, that the radio waves leaves the antenna. The tower was designed by Professor Henrik Kühler, and the antenna was developed by the Swedish American Ernst Alexanderson, who also has developed the alternator, the transductors, and the magnetic amplifier. The antenna had a very high efficiency when it was done, almost 13%. Today we have about 10%. We are transmission today with about 80 kilowatts, and that means that about 8 kilowatt goes out on air. Here we have the beautiful radio station built in neoclassical style and designed by architect Carl Åkerblad. Now we just have 4 minutes left for transmission. I am back, and I think Jan-Åke is satisfied. You are satisfied. You are satisfied with the frequency, and it's okay. Then we have to prepare for the transmission of the message. I think it's time to stop the reader. Just stop the reader. We can wait some minutes more. In the meantime, we leave the camera for itself. We have to do some preparations, fine-tuning and so on. Thank you, Kai, for sending the message. Impressive. That was the message from Radio Grimeton this Alexanderson Day. And you have seen it on the screen there. It's an important message for us, because in the summer 1923, 100 years ago, the equipment to build this amazing transmitter station arrived here in Grimeton together with a special team from General Electric. This station has gone soon 100 years, is still functioning, can be heard by listeners almost over the whole world. We have one listener's report today from Tasmania. It's a long way. Yeah. So it's fantastic. We have listeners over the world. We can show the transmitter on YouTube and show it to you in the audience. By that, it's time to stop the machine, which we do in the opposite way of starting up. So Jan-Åke will start to open the nice switches, and I will go down and stop the motor. And Jan-Åke can stop the rectifiers. And he will also lower the liquid level in the liquid resistors to the start position. Later on, he will stop the cooling fan, for we have no use for it anymore. When the motor speed is slowing down, the internal oil pump can no longer handle the oil pressure, so we have to connect the auxiliary oil pump again. We will have a signal. I will go down there. By that, by this, I will. Yep. By that, I will. Close the auxiliary oil pump, and it takes about 9 minutes to a complete stop of the alternator. So by that, we have finished our mission today to start up and send a telegraph message over the world. We hope that you have enjoyed being with us on YouTube, and that our listeners out there, that is okay. We hope that you enjoyed the start up and reading the Morse coded message. And to our listeners, send a listener's report. It's of great importance for us, and we will send you an electronic QSL. And check in on our website. There you can read more about how to send a report, about information about our association of upcoming transmissions, and of course how to be a member. We want you all as members, so join us. By that, thank you very much. Welcome back. Bye-bye.